Okay, so today what we are going to be talking about is geoprocessing. Geoprocessing. Geoprocessing is an important aspect of GIS, and you cannot undertake spatial analysis without having to run some geoprocessing analysis, right? So in GIS or in QGIS, we have what we call geoprocessing tools under the vector layer. Even in raster analysis too, we can also undertake geoprocessing. But what we are going to concentrate is geoprocessing under the vector analysis. And when we are talking about geoprocessing in GIS, it refers to a set of operations and tools used to manipulate, analyze, and manage spatial data, producing new data sets or insights from existing ones. So what we are talking about geoprocessing, we are saying that it's a set of operations and tools. So when you open QGIS, we have a set of geoprocessing tools, right, that we can use them to undertake analysis in a form of, with the help of the geoprocessing tools, we can manipulate already existing data. It can also help us to analyze data in any format of our choice. And it also helps us to manage spatial data. When you do this, when you undertake spatial analysis or try to manage spatial data using geoprocessing tools, at the end, it returns a new data set to you, right, apart from the main layer. So what happens with geoprocessing is that, let's say you have the shapefiles of Ghana showing the boundary of Ghana, and you want to undertake a certain geoprocessing analysis, right? Let's say you want to create a buffer of 100 kilometers around Ghana, right? 100 kilometers around Ghana. You see, so when you use the Ghana shapefile to create that buffer, in the end, what is going to return, right, it's not going to merge with the existing data or existing layer. It's going to return a new layer to you, right? So in terms of geoprocessing analysis, when we are doing geoprocessing analysis, when you have an input layer, right? Then you specify the analysis that you want to do. In the end, it returns a new layer to you. Geoprocessing is a framework of GIS operations that take an input data set, such as a map layer, a raster, or a table. As I said, the input data can be location of universities in Ghana, right? We can use that and perform a spatial or data transformation. So we can use the universities of Ghana. They will perform geoprocessing analysis using something called, let's say, buffer. And then we say that create a distance of 100 miles around all the universities so that we can see how many of the towns in Ghana are located within 100 miles of the universities. Is that okay? So let's say you want to draw a circle, right, around your community, some part of your community, and you want to count how many houses are inside that circle. So let's say you can have a borehole facilities, 1 or 2 borehole facilities in your community. Then you try to draw a circle, a buffer around it, a buffer of 10 kilometers to see how many of the houses are located within 10 kilometers away from the borehole, or how many of the boreholes are 10 kilometers, yes, away from the borehole. That is the buffer, so that you can see maybe there is a standard that says that every house should be located not more than 10 kilometers away from a borehole. That means that when you do that and you have people away from the 10-kilometer circle, that means that those houses do not have access to the borehole or the water facility. Do you understand that? So now, so we are saying that whenever you undertake geoprocessing analysis, it returns a new output data set. So examples of geoprocessing analysis include, we have buffer, we have clip, we have dissolve, we have merge, intersect, we have union, right, and many others. But for now, we are going to stick to these ones. I will show you a graphical representation of all this, and you understand them very well before we proceed to the practical session. What is the purpose of geoprocessing analysis? It allows users to automate workflows, conduct spatial analysis, and manage geographic information efficiently. As I said earlier on, you may have a data set that is too huge, right? You want to perform a certain analysis and you want to extract part of the data, right? That is your area of interest. So let's say you have a data of Ghana, showing all the 10 regions of Ghana, having the roads and so many things in Ghana. Now, you want to undertake analysis in Kumasi here. You are not interested in what is existing in Tamale. You are not interested in what is existing in Bolgatanga or what is existing in Accra. So with the help of geoprocessing, you can clip what is in Kumasi by using the layer of Kumasi, the boundary of Kumasi, and you can clip the features of Kumasi, and that is your area of interest. You can work with that. Is that okay? Now, what we see here, as I said, examples of geoprocessing, we have dissolve, we have merge, we have clip, we have intersect, we have union, just like in mathematics, right? So now what we have here is what? Dissolving features. Dissolve is a feature, is a geoprocessing tool, right? So now you can see from here, we have this square. Can you see? And then we have different symbols categorized in here. We have green, we have blue, and we also have violet. Now, this is the output coverage. This is the input. But you can see here that it has been dissolved. The dissolve here is that you see here, when we check under the green, how many features do we have? We have 1, 2, 3. So now these 3 features have been dissolved together to give you this. So let's say the input ID of this, let's say this one is 1 and this one is 2, this one is 3. So now they have been dissolved. You have dissolved the 1, 2, 3 to get you at this. Is that okay? And when you also check within the green area, we have 1, 2, 3 features. And when you dissolve them to, you also have something like this. And this side to the same thing. What the function of the dissolve, you can see that, let's say, maybe you have Ashanti region, right? And in Ashanti region, you have so many districts in Ashanti region, but you want to get the boundary of Ashanti region. You can dissolve all the districts in Ashanti region together to give you the boundary. So that is what you have here. So let's say these are 3 districts. You dissolve them together to have one. Similar thing to this side too. Now, when you check here too, so what the layer you put first, right, to run the analysis is what you call the input layer. And what you get in return is the output layer. Is that okay? So you can see here it's named as input coverage and output coverage. But in basic terms, it's called as the input layer and then the output layer. So the input is what you input or you choose, the layer you choose, the mother layer, the main layer to run the analysis. And then the output, the return is what? The output layer. So you can also see here too, we have 3 rectangles, right, together. And when you dissolve them together, you can see now we have their boundary. So let's say these are different districts. Let's say this is Greater Accra and this is Kumasi, let's say regions. This is, let's say, Greater Accra, Ashanti region, and Northern region. Now, when you dissolve them together, you now have only the outer layer together. And now, what happened with dissolve is that what you see here, they are all standing with what? Unique feature. So when you open the attribute table of this, for instance, that means that this one will be standing alone, that will also be standing alone, and the same applies to this one too. But when you dissolve them, it returns with what? One feature, right? So you can now see that here there were 3 features. When you dissolve them together, now you have one feature. The same with the first one. You can see under the green side too, like here was 3 features. You dissolve them together, you have 1 here. This place also 3. You dissolve them, you have the same thing. Now, when we check at the extreme right hand side, we have dissolve attribute. You can see we have a table, right? You can see we have a table here. That is the attribute table. And then the map here, you can see that we have 2 polygons shown together. So you see at the table here, we have about 3 columns. 3 columns, right? 2 columns here rather. There are 3 in general, but our interest is the 2 here. So the one in the ash color, right? The 2. When you dissolve them together, this is what you have. That means that, you see, when you put these 2 polygons together, you dissolve them together, you see this line will disappear and it will now turn to one. That is what we have in the right hand side too. And then so that means that it will also dissolve this together. So this attribute and that will just will what dissolve together, and the second ones to also be dissolved together, and in the end we now have only one column. When we come to down to the same thing, I think this is a map of the US or Canada or something like that. So you can see we have so many provinces. You can see under the yellow, under the green, under the violet, and under the blue. So we see when you dissolve them together, you see you now have something like this, right? So this is the input and that is the output. And we also come here to the same thing. We have a circular object, right? And also have a rectangular object, and you can see that they are intersecting, right, together. And now when you dissolve it, you have something like this. And then the last end to the same thing, we have a map here showing what you can see that we have different polygons with their boundaries. And when you dissolve them together, you have something like this. So you see, so the blue have been dissolved together, the green two dissolved together, and the black side too is also dissolved together. So then we're done with the dissolve. The next thing is what? Clipping features. So for clip is very interesting. Let's say you have the map of a community, right? Or you are dealing with an area. Let's say you are dealing with an area, let's say Ghana, right? And you are undertaking a project in Accra, and Accra is part of Ghana. You are not interested in all the features of Ghana. You are only interested in Accra. Clip helps you to go and what? Extract only the features of Accra. That is your area of interest, and work with that. That is the function of clip. So the clip tool casts out an input layer to a defined feature boundary. What's happening with clip is that before you can clip an area, you need to have a polygon, right? That specify the area of interest you want to clip. So you can see here we have the input, for instance, right? And this is the clip feature. The input is the mother layer, the one that contains the features that you want to clip or you want to extract some features from it, right? So let's say this is the input layer, and the clip feature here is what? That is the circle. So now you want to put this circle inside this square and clip and cut up some parts of it, right? So when you put this circle on top of the rectangle here and clip, this is the results you are going to have. Can you see? And now when you come to this place to the same thing, you can see we have some plus symbols all around the place. When you use the clip feature, so the plus sign that we have here is the input feature or the layer, and the clip feature is the circular here. So when we place this circle, right, we use this clip feature and say, okay, go into this and clip all features that fall within the circle, right? So the clip feature is in the sense that it's going to return features that fall within that polygon. So when I clip this, you see in the end, you have this part of the symbols falling within the circle. Now, when you come down here you have some lines crossing each other or what? Yes. And you can also see that they are intersecting all over the place. Now, we clip them using the clip feature here. You see, it returns to us what? Rows in what? In a circular format. Now, let's look at the raster. As I said earlier on, when we are talking about geoprocessing tools, it doesn't mean that you can only do that in vector, right? You can also do that in what? In a raster analysis. It's like you are having a picture, right? And you see, you have a group picture. You want to extract one person from the picture or yourself. You can crop the picture, right? And then take away the other people in the picture, remaining only you. Or the picture can also be you, but you are interested in showing only your face. You can crop out your what? Your hands, your chest back to your what? Your feet, and you only retain your what? Your passport picture side. So now the raster feature we have here, you can see it's a satellite what? Image, and in there you can see a yellow layer, right? That is like a polygon around it. So you see, so you can clip the polygon, and now when you clip it, you see this is the resultant feature. So you clip your area of interest, and you can see now inside the raster file we have That's part of it carved out. And now we also have what we call creating a data subset. Creating a data subset is not a main geoprocessing tool, right? But you see, when you clip, right, that here, when you clip this, what you have in the end is what? A data subset. You can see what we have done here. You see, when you clip here in the end, you have this, it's a data subset, just like you have sets where we have a subset, right? So you can see that this is part of this. When we input it, it will give us what? The whole. And you can also see that from here to, we clip this from here. So the output is what? Is termed as what? A subset data or a data subset. The same thing happens to this place too. You can see that this place is now empty, it's hollow, and we have the sub data set from here, and when we place it back, it gives us a whole. So that's the same thing here. So now you can see that we have some symbols here all over the place, but some of the symbols fall within the polygon, right? So let's say this is the area of interest. You are working with this area, you're only interested in the symbols within this. So now the symbols you have here is what is the input features, right? And this polygon you have here is the clip feature. So now I will use this clip feature, the polygon, to clip this feature. So it will return these symbols back to me, right? So let's say you have the map of Ghana. You are interested in the number of settlements, or you're interested in the schools in your town. Let's say Wa municipality. And let's say if this was the boundary of the Wa municipality or Wa province, you can use this as the clip feature, and you can clip the schools that fall within only that. And this is the output you have. Now we also have what we call buffering. We all know what is a buffer, right? So you have something that you want to create a distance around it so that people cannot encroach or they cannot come near that, right? Or you want to create a buffer of a certain distance of interest. So now you can see here, I have an input, right? Let's say you have a road, you are a civil engineer, you are going to construct a road, right, from Accra to Konongo, and there are some certain facilities or stores that are located along the road. Now, you are saying that the width of the road is going to be what? 90 meters. So that means that all buildings that are located 90 meters away from the road or 90 meters within where you want to construct the road will be demolished. So you can use the buffer and you can create. So if this is the road, you can create a buffer around and you can see the buildings that fall within the buffer, and then you can demolish those buildings. So you can see what we have here, this input feature, right? And now we have created a buffer around it. Can you see? That's about 3 buffer. So you see the blue buffer, and we also have what? The green buffer. So that's about 2 buffers. So with buffer, you can only create a buffer using what? Distance, right? So rather that with the clip, right? You see, we're having the clip and then the dissolve. Those ones that don't necessarily have to use distance. Unlike here, the buffer, you can only do buffer using what? Distance. Now, when we talk about buffer works for points, buffer works for lines, and also for a polygon. So you see here, we have this one is a polygon, and we have created a buffer of a certain distance around it, right? When you also come here, we have a point. Can you see the point in here? Some black point inside. And we have created a buffer of certain distance, rings around it. So we have the blue ring, the green ring, and we also have the orange ring, or is it a gold ring? You see? And when we also come here, the same thing, we have these 2 symbols here. One is here, another one is here. And now we have created a buffer. So that's the input cavity. Can you see the buffer here? I've created a buffer around this one, the bigger one, and the smaller one. Now you have to observe something here. If you are creating buffer, you realize that you can create different distance around it. That doesn't necessarily mean that it has to be one, right? So you see, it can be single, it can also be multiple, or it can be bivariant, right? This plays to the same thing. Look at the points we have here. We have 3 points, 1, 2, 3. That's the input. Now we have created a buffer around it. Can you see the circles around it? All the 3 points together. Same thing here. So output dissolve. So the dissolve that I was talking about, you can see with the dissolve, you see when you create the buffer, you can dissolve the buffer together, right? It's like you have an ice, right? Ice. You put one at one side, another one at one side. for a certain time, they are going to dissolve. So you realize that the water will be flowing. There will be a mixture. The water will be flowing into what? Into each other together, right? The same thing here too. You see, I was saying that you can also use a buffer. It's not only in lines. Buffer, you can apply buffer in points, in lines, and in polygons. So you can see this is a line. So assuming this one was a road, and we are saying that no one should locate a shop around this side, a buffer of 10 kilometers. So you can see that there's a buffer here around the line. So you can see a line inside. That means that no one is allowed to build inside here. When your building is found here, that building is supposed to be demolished. Now, when you dissolve the buffer here, this is what it's going to give you. So you see how the dissolve function work and the buffer. So when you create a buffer, you see there's an overlap in the buffer. Can you see there's an overlap? But when you dissolve it, it put them together, right? It give you one unique, right, harmonized feature around where you can see it well, and then what? You can appreciate it better. So you see, you can see that here, the buffer return what two different features, one around the side, another one to at that side too. That's why they are showing them with different colors, even the first one. But when you dissolve them together, it gives you at one unique feature. The same thing to this place too, as you can see. When you come here to the same thing, you have the line buffer. You can see a line where they have created a buffer around it. And you see when you dissolve it, it gives you like this. Similar thing to this side. Now, when we are talking about buffer, as I was saying, we have different type of what, or different ways of determining what buffer distance. We have the constant distance, we have the variable distance, and we have the multiple ring distance. So the constant distance means that you have locations. Let's say these are schools, right? Point, 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 and you create only right one constant distance around them. So you can see that all the points, the buffer around is the same. So let's say that is 2 kilometer, 2 kilometer all around. That is what we call constant distance buffer. And we have the variable, right, or the variable distance. So you can see here we have that same distance around here, those same points. But the buffer we have created around it, the distance varies, right? So let's say we have 10 kilometer buffer, we have 2 kilometer. They also have what 20 kilometers. So you can see the circles what vary, right? So that is what varied distance. And we also have the multiple ring. So the multiple ring is in such a way that you can do sensitivity analysis, right? You can create same point or same location, different distance. So I can say that this point, I want you to create a distance or a buffer around, create 10 kilometer buffer, 20 kilometer buffer, 30 kilometer buffer, 40 kilometer buffer. So it will return with what multiple rings or different distance of buffer around it. So that is what we are supposed to know with regards to the buffer with the geoprocessing tools. So from here, we are now going into the practical aspect to see how we can apply that. going to select using what? The normal hand select, right? So once you activate the select feature like this and bring it here, you realize that your pointer changes to what? A black symbol. So you come to where the Ashanti region is and you click on it. So once you click on it, it's selected. You can see that it's now shown as a different color apart from the other ones. Let me increase the width of it so that you can see, you can appreciate it better. Let me increase the width of the polygon. Okay. So now we can see, yeah, Ashanti region is what is selected. But the layer we have here, there is an overlap. That is the reason why we're trying to select with expression, and they are telling us that the layer does not exist. There's an overlap here. But let's try and see. That there's problem with the layer. Ashanti region should have just been here. It shouldn't be overlapping. Now, once I highlight it this way, then you remember the method we follow to create. You now come and right click on the new region shapefile. Then you come here to the export, right? And choose what? Save selected feature as, remember. So you right click that and you go and choose the file name where you want to save it. So I'll name it as what? Ashanti region. So once you are done, you save. So you make sure you choose the right coordinate system here. So that is the WGS 1984 UTS zone 30. So once you are done, you click OK. So you can see now we have a layer, Ashanti region layer added here. You can see. So this one is what driven out from where? From the Ghana layers. I hope you can see that. So you can now see the map of Ashanti region shown here. So that is the clip feature. So what we just did is called what? It's called the clip feature, right? We have clipped by selecting this side. Is that okay? Now, we also have the rows, right? Shown here, the national rows. Can we see that there are some rows passing through Ashanti region? Now that we now know this is the boundary of Ashanti region, we have some rows passing through. Now we want to clip. We are interested in only the rows passing through Ashanti region. What we can do is now to use what? To use the clip, another clip feature from the geoprocessing, so that it will only give us the rows in Ashanti region only, right? So now I will go to the vector, go to geoprocessing, and select what? Now we are selecting the clip, and under the clip, the input what? Feature is what? We are choosing what? The rows, right? The national rows, and we are saying that the clip feature is what? Ashanti region. It should only return to us the rows in Ashanti region. So it will clip only the rows in Ashanti region. It will not extend outside. So once I select this, then you come and click on what? Run, right? And you close. So you can see. So now I can turn off the national rows, and you can see the rows only in Ashanti region. Can you see that now? The Ashanti region rows. So let me change the color. That is at the top here. That's the clip. Returning to us only the rows in Ashanti region. I hope you can see that. So that's the national rows in Ashanti region. So now that is how the clip 2 works. So the clip and the intersection, they work similar. We can use the intersection to get same results. So we have the Ashanti region and we also have the national rows. We want to get the rows that fall within only Ashanti region. We can go to the vector, same process, geoprocessing tools. They will now choose what? The intersection, that's the intersect. Now, our input layer is what? It's the same thing. The input layer is what? So now we are going to pick the Ashanti region, right? And we are saying that it should intersect what? So that's the overlay. Is what? National rules, right? And we run. So you can see that it has returned this thing. No, it did not return the right layer for us. Let's do it again. Let's do it again. So we'll go back to vector, the geoprocessing tools. We pick intersection, right? So we pick the national rule. Now the overlay is what? That is the layer. So the national rules that are right? That is the input layer. And when the overlay, what is on top or what says within the boundary. And here we are choosing what? Ashanti region. So once we do that, then we run. So now you can see that we have the rows also added here. That is so that the clip and the intersection can give us similar results. So let me change the color so that we can see it well. So we can see the rows here, right? So that is how that one too also works. So now we also have, so now we know how the buffer works, how the clip works, how the dissolve works, how the intersection works. And now it's now that we have to use what? The union. Now we want to see how the union also works. So now with the union, I'm going to, let's go from the new Ghana regions. We already have Ashanti region. Now we want to create another region to and add, right? We want to start one of the regions. So now we want to take off Savannah region, which is here. So I'll use the select tool again. I'll come and click and select the Savannah, right? So make sure you select the layer first. So it's selected. So I'll come and right click on the new regions and go to export and save selected feature as.
Hello.
So, yes.
What feature do you use to do the selection?
It's at the top there. That was the feature we used last week. Have you seen it? Select features.
My area.
Can you see it? Select features.
Okay.
That tool, yes. So I will right click on the new regions. Then you go to export and save feature as. So this time around, that is what Savannah region, right? So I'll save it Savannah region. Okay, then I'll click on okay. So we have Savannah region also selected. So now when we turn off the Ghana region, we can see that now we have Savannah region and also have Ashanti region, two regions selected from the Ghana district. Now you see, now when I click on Savannah region, it's selected. When I also click on Ashanti region, when I also click on Ashanti region too, you see that it's also selected. Now, that means that they are standing alone, right? But now I want to union them together. So that's where we are going to now use the union tool here. So I'll go to the vector, come to geoprocessing, then come to union, right? So the input layer, I will choose Savannah. Where is it? There's Savannah here. We also have the overlay, then I'll choose Ashanti region, right? Okay, then you run together. So you see, it has returned a layer to us. Can you see the union at the top with the name? Can you see the union? Now they are now all the same color. You can see it has union them together and they have the same features. When you go to attribute table, we have two features that will be shown. So you can see one here. We have Savannah selected, and I can also select Ashanti. Now, what's happening is that if you don't want to use them from here, from the geoprocessing tool, you can equally come here to the processing toolbox. Remember, I told you earlier on that you can always open here. You can search any tool that you want. So when I come here, then I choose and I search union. You can see that the union has appeared here. And when I click on it and open, the same thing, I can use it to run the same analysis. So when you forget the location of the tool, but you know it, you just have to come here and search the name. Now I want to search and see whether we have merge here. We have merge here. You see now they're saying that combined style layer database. We have point cloud. So we have what? Merge vector general layers is here. So let's so I also have what? Merge lines. So if you have two lines together, you want to merge it. And also have merge vector general layers here. So you can use same to undertake your analysis. Right. So now we are going to select the features we want to merge together. Now I want to merge Ashanti region and also what? Savannah region. So I've selected the two here. Once you are done with your selection, you can return back. You see that they say two inputs selected. So once you are done, the destination, you want it, you choose your coordinate system, which is 30, and you save where you want to save it to. I don't want to save, so I'll run. So once I'm done, you see they have returned the merge to us. Can you see the merge layer here? Now it has put them to. So we see how that one works, right? That is how the geoprocessing tool works. So you can use it to clip your area of interest, to buffer, to merge, and things like that. So many things. So I think we are done with how the geoprocessing tools work. Even though in subsequent lessons we will explain further how to extract features from this to use them and undertake steady area map or steady area analysis. Yes, or even most of these are explained in the advanced QGIS. Now we're just doing introduction. So some of these things, if you have to go beyond here, they are advanced format, right? So you can explore them yourself later.